now, this, and also I showed some 3D graphics visualization of CT images. So human anatomy is vividly observed from 3D visualization. So CT images are very detailed, high resolution whole body images now acquired in a daily clinical routine. And also we also addressed two-dimensional X-ray images. So this is viewed as 2D projection of 3D CT image. So this slide shows target structures of our research, that is musculoskeletal anatomy of the hip and thigh. So this figure shows some muscles of thigh and hip. This is frontal view, and superficial muscles and deep muscles. This is back view. So there are a lot of muscles. So our system reconstruct patient-specific anatomy of muscles from 3D CT data, even from MRI data. And also, furthermore, our system reconstruct patient-specific musculoskeletal anatomy from two-dimensional X-ray images. So this picture shows well-preserved Japanese old-style architectures, Gokayama in Toyama. If you visit Japan, I encourage you to visit this place. So next, I present musculoskeletal CT segmentation system. So this is CT image, cross-sectional images. I'm afraid you are not very familiar with this kind of images. So at this image, there are a lot of muscles. So in this images, contours, two-dimensional contours of each muscle region are overlaid. But still, you are not very familiar with this kind of things. So this is one slice images. So if we stack these images in 3D and to reconstruct these three-dimensional structures of muscles and bones. So this is enlarged view of CT images. Roughly speaking, this white part is bone. This bright gray part is mainly muscle. And this dark gray part is fat. Of course, boundary between outside body and inside the body, this is skin. So maybe you can now recognize what is muscle, what is bone, what is fat. But still, it may be very difficult to identify each individual muscle. So each region are different. Each region is different muscle. So our final goal is segment, delineate these muscle boundaries accurately by deep learning. So we use slice-wise segmentation. So that is region recognition by so-called UNet. UNet is very, very famous deep learning models. So give training data sets, CT images, and so-called label images, that is accurate muscle regions, ground truth data of individual muscles. So this deep network UNet is trained so that given input CT images, so as to output this label images of individual muscles. So to do so, of course, training data is very important. So actually, we used 20 cases of CT scans of pelvis to knee, uh, so as training data. So 20 cases sounds not very large number, but one case has around 500 slices. So resulting 10,000 slices are available for training. So in this training data, so 19 target muscles are annotated by expert surgeons. So according to anatomical textbook. So this is CT images. This is annotated label images. This is superimposition of original CT images and label images. So this slide shows training of UNet deep learning model. So this is ground truth label images. This is input CT images. So this is output result by UNet deep learning models. So please look at this. Firstly, this results output relatively random result, but as training progress, this should be close to ground truth. So I showed some training process. So firstly, random shape happens, but as training progress, this output become close to ground truth data. So now almost converged. So this is one of typical result, but this is very difficult cases. So this is ground truth. This is hand manually annotated data. So this is UNet deep learning result. So this is so we have been working on this problem more than 10 years. So before deep learning, we used so-called hierarchical multi-address method. This method was not very bad, but in this case, it's very difficult. So the result was not very good. For example, look at this red muscle. This muscle is very close to ground truth in deep learning UNet methods, but in this non-deep learning method, the result may not be very good. And also error, quantitative evaluation, error was in average 4.7 millimeter, here 1.37 millimeter. So deep learning method is much more accurate. So this is quantitative result. So in average, so non-deep learning method error was 1.56 millimeter, deep learning method 0.99 millimeter. So if you may think non-deep learning method may not be very bad, but even human annotator maybe error should be around 0.5 millimeter or more. So that means so this line should be baseline. So maybe so deep learning method will be much better than 0.99. So this is this heat map shows error of so horizontal axis represent different muscles. Vertical axis represent different patients. So for any patient, for any muscles, so UNet deep learning method is was smaller error that is less than 1 millimeter in blue area. So in non-deep learning method, mainly so 2 millimeter or something like that. So in our experience, if it is blue part, that means almost 0.0 millimeter error or less. The result is directly applicable to clinically. And also, more importantly, in non-deep learning method, processing time will be 1 hour or more. So deep learning method, a couple of minutes. This is another very important advantage. So this slide shows inter-patient variabilities of muscles. Uh, uh, so these are examples of automated deep learning segmentation. So these two patients has heavily diseased hip in one side. So this leg became very short compared with the other leg. So, and also muscles becoming very thin compared with relatively healthy hip. So these two patients, relatively mild patients. So, so these are in these patients, left and right muscles thickness will be similar, but compared with this patient has much larger muscles here. So, so each patient has so different muscles feature. So once each muscle regions three-dimensionally segmented, so we can evaluate quality of muscle. So here, so red part means muscle tissue. So that means a healthy muscle tissue. So yellow part shows fat tissue. Tissue is not very healthy if it is inside muscles. So this is one side. This is the other side of the same patient. So this patient is relatively severely, so severe cases. This is mild case. In mild case, both muscles are relatively red. So severe case, one side is so some parts are yellow parts. That means fat parts are there. So and also we can calculate the volume, muscle volume from segmented muscle regions. So healthy muscles, patients, so maybe, so muscle volume is very similar. Uh, so, so severely diseased patients, muscle volume maybe 60%. So moreover, fat regions, uh, many fat regions are included in this muscle. So healthy muscle regions will be much smaller than 60%. So after once we got segmented muscles, we can also evaluate these kind of analysis. So for other muscles, we can do the similar things. So in summary, so UNet, one of the most famous deep learning segmentation tool, was applied to muscle segmentation from CT. Nowadays, this work is just one application, but received great clinical attention because of uniqueness of application domain, and therefore may open up new researches, which I will present from now. So this picture shows ruin of a castle in Okinawa style, southern island in Japan. So actually, these pictures are taken by me. So next topic, our efforts to address problems in AI. First, a black box problem. So we, in order to address AI's black box problem, we developed Bayesian unit for uncertainty estimation. So again, this is results of deep learning results. and this is ground truth. Uh, but could you try to find what kind of mistakes unit deep learning made? Maybe you find this one is missing in deep learning compared with ground truth. But maybe other mistakes, it may be not very easy, even you compare with ground truth. Moreover, in clinical, real clinical situation, they cannot use ground truth. So in that situation, how we can use AI results in a clinical medicine? So we developed Bayesian unit. Actually, this PhD student developed this method. So, so Bayesian unit outputs not only segmentation results, but also uncertainty. Uncertainty means so maybe unreliable segmentation path areas. So of course, this uncertainty is calculated without knowing ground truth. So this shows actual error regions. So compared between uncertain regions and actual error region, you can observe very similar structure. For example, so this missing structure is very uncertain. So in a clinical setting, situation, so if clinical people observe this uncertainty, so they can check this part is correct or not. And so they should modify this part or not. So you can check only these parts. So if this is actually very difficult cases, so so a lot of uncertain parts are shown, but usually not so many. So maybe this is a slide shows what kind of method used to estimate uncertainty is segmentation. Actually, this idea originally developed by Hinton, of course, very famous researcher, and then firstly applied. So this researcher applied to uh, picture segmentation, and then our students applied to unit like this. So he inserted a dropout layer. So what is dropout? So if if deep learning trained very well, if some dropout happens, maybe some connections deleted, result is very stable. But some parts are not very well trained. In this case, if dropout happens, uh, result will be very unstable. So we tested several random dropout patterns, and if still result is the same, maybe very certain. So result is very unstable. This is uncertain. So uncertainty is calculated by variance of the output result of different dropout patterns. So this is correlation between uncertainty and actual accuracy. So in any structures, we had some relatively high correlation. So in average, 0.7 as correlation coefficient. So summary, uncertainty. So uncertainty is high when AI is not confident about its output because of insufficient training and suitable input data. So segmentation accuracy can be predicted by uncertainty obtained from Bayesian unit. So accuracy prediction will be useful for finding reliable results in clinical use in large-scale analysis and selecting additional training data to effectively improve the performance of AI. So finally, I talk about extensions to highly capable X-ray image-based AI without additional manual annotation. So now it is possible to generate a lot of muscle and bone segmentation results. So my colleague, Professor Otake, have already segmented more than 10,000 cases of CT images. So we are now easily obtained of this kind of muscle and bone segmentations results. So automatically segmented 3D CT data might be somewhat noisy, still somewhat noisy, but will be very rich and sufficiently accurate for training of AI for two-dimensional X-ray image recognition. So this is two-dimensional X-ray images. So you can observe some bone, pelvic bone and femur bone here, but it may be not very easy to see muscles here. But of course, muscle is images here as well. Actually, we did some image processing to enhance boundaries. So this boundary actually muscle boundary. So some kind of muscle information will be here. So in computer vision domain, so given three-dimensional training data sets, for example, so conventional RGB photograph and three-dimensional depth images and segmented level image. So given this training data set, so of course more than 10 years ago, around 10 years ago, they have already succeeded from just RGB color photograph to output depth images and segmented level images by deep learning in 2015. So similarly, we can do that, similar thing. So RGB photograph, something like two-dimensional X-ray, and depth training data, something like CT images. So CT image segmented data and labels segmented results. So if we have these training data sets, so we can now automatically generate a lot of these data. So we can train deep learning to infer so these kind of three-dimensional information from 2D X-ray images. So actually, we generate training data set from CT images and segmented bone and muscle region. And then we generated so-called DRR, digitally reconstructed radiograph. This is actually simulated X-ray images and each bone and muscle. This is pelvic bone simulated X-ray. This is the muscle. This is femur bone simulated X-ray images. Actually, this image should be summation of these images. So, given these images, we can train deep learning model to decompose into these individual simulated X-ray images. So this is one of results. Given this input images, so we decompose this image into these decomposed images. So pelvic images, femur images for other muscle images. So actually, this kind of processing is possible using so-called DEXA imaging system. So this imaging system use two different energy of X-ray to segregate bone tissue and muscle tissues. So, but this is not very common. So, using these images, so bone mineral density can be calculated, and also muscle mass can be calculated. But without using this kind of images, our decomposition, AI decomposition uh, system, we can decompose bone part, muscle part, and also individual bone and individual muscle. So we can uh, we can produce some kind of virtual DEXA images by using AI from plain X-ray images. So we did that. We developed some methods. So from X-ray images to decompose, we firstly decompose each muscle and bone images, and then we use separated bone images. So from this image, so we can calculate it, so bone mineral density by only from X-ray images. So our method shows high correlation between so DEXA measured bone mineral density and our predicted bone mineral density from plain X-ray images. So now without special massing, there is a possibility to measure bone mineral density. So similarly, muscle mass can be estimated from plain X-ray. So, this PhD students and our collaborators have already shown high correlation, for example, 0.86 or 0.87 or something like that, obtained between our predicted muscle mass estimation from plain X-ray and muscle mass measured from CT image. So in summary, so bone mineral density can be accurately estimated from plain X-ray images. Muscle mass can be estimated from plain X-ray images as well. So in this application, training data was constructed in a fully automated manner. That is, manual annotation cost is zero. Annotated data was constructed from automatically segmented CT data by AI. So summary and future plan. So development of CT, musculoskeletal CT segmentation system is presented. And also we present our efforts to overcome problems in AI. First, for black box problem, we developed Bayesian unit to estimate uncertainty. And then to address annotation cost problem, we extend to X-ray image AI system without additional annotation, which results in a so-called virtual DEXA plus images from plain X-ray images. So future perspectives, we are now extend our CT segmentation and X-ray prediction system to whole body musculoskeletal anatomy. So, and also detailed, also trying to modeling detailed anatomy, including muscle fibers, tendon, ligament. And also we try to apply our method to clinical study. For example, artificial hip joint patient. So, and also we are trying to develop system for fully automated personalized biomechanical simulations. Thank you very much for listening. That's all.
Okay, thank you, Professor Sato, for your nice sharing presentation. I hope you will still join with us because right now we're going to the next our invited speaker. For the question, maybe after the invited speaker presentation, we will open the question for Professor Sato and Professor Jati Utomo. Here is already accompany me in the States, Professor Jati Utomo Dwi Hatmoko, ST, MM, MSc, PhD. He is a professor in Civil Engineering Department of Diponegoro University. His research interests include sustainable construction, supply chain management, risk management, digital construction, and right now, he is a head of Department of Civil Engineering Faculty, Diponegoro University. So, time is yours, sir. Okay, there is the slide, I think, already shared.
Okay, good afternoon, ladies and gentlemen. It's my honor to be here to present some of my research, and I understand that this is the last session. Yay! Yeah, I think everybody is happy because this is the last session. So I'll try to make it quick. I have given 30 minutes, but I have 27 or 28 slides, so I might skip as necessary. Okay. So this is the topic of my presentation. It is about managing construction risk through digital transformation. I believe because I'm from different background, I'm from civil engineering background, so I might bring a different perspective on the topic for today. So to begin with, I'd like to show you, there's a quote from Hammurabi's code, this 1792 BC, and he says that if a builder builds a house for a man and does not make it construction firm, and the house which he has built collapses and causes the death of the owner of the house, that builder shall be put to death. So this is a reflection of how important this is for, especially for civil engineer, to take care of anything that may bring the house or the buildings to collapse. So we have to take care of any risk that might happen. So indeed, we have to admit that in the construction industry, we are still having many problems related to delay, low quality, cost overrun, and safety. As all the pictures shown here, we can see the scale of this problem. And this is not only happening in Indonesia, it is globally also happen, including in developed countries. So this is what may happen if we neglect risk. Some pictures from Indonesian projects. This is under the Ministry of Public Works and Public Housing. We can see here many examples of construction collapses because of some neglection of risk. So defining risk is not always easy because it says here risk is an abstract concept, difficult to define, and in most cases it is very hard to quantify with any precision. If we look at what Oxford Dictionary tried to define the risk, it says the possibility of meeting danger or suffering harm or loss. So in general, in the context of everyday life, risk is described as a chance of unfavorable things or unfavorable event that might happen. And there are many variations of risk definition. I quote some of them here. From Smith 99, it says here that risk characterized situation where the actual outcome for a particular event or activity is likely to deviate from the estimate or forecast value. And risk is a function of both the probability and consequence of failure. And the third one, a threat of or opportunity which could affect adversely or favorably of the achievement of the objective of an investment. So in this case, now we learn to understand that risk is not only negative but also in a positive way. Like also this definition is adopted for ISO 13,000, I mean. So of course, risk versus uncertainty is a common question where we can say that risk is always containing uncertainty, but not all uncertainty is risk, depending whether or not this uncertainty will deviate you or prevent you from achieving an objectives. And three elements of risk: the event, the causes, and the consequences. These are normally three things which we look at when we are talking about risk. And the risk characteristic here, this is hierarchical, it is multidimensional, and this is multiple perspective and dynamics. And if you look at the picture on the left bottom, it is showing the total project life cycle. What we can see here that the risk might happen during all the phases of the projects, and we have to look at which period have the highest risk impact. And on the right-hand side, we can see here the hierarchy of the risk, where we can see here the more strategic decision, the more uncertainty that we can have for a project. The risk also is characterized as multidimensional, multiple perspective, and dynamic. It means that the risk might change during the project life cycle. Okay, this is a risk management framework from Zhu et al. 2015, where we can see here that during all the project life cycle, the project phases, from the planning, design, construction, and maintenance, operation, and demolition, we can always have risk analysis process throughout the project life cycle, which include the identification of risk, the analysis, the evaluation, the treatment, and the monitoring. And also it may involve different stakeholders, as we understand that in every phase of the project, we may have different stakeholders, from the designer, from the consultant team, the client, the vendor, and so on and so on. Okay, these are some risks that can be identified from different phases of construction project. For example, in pre-construction, we may have risk of having problem with permit or delay in the handover of the project location, or perhaps long duration of client decision making, unclear details in design drawing, completeness of the contract, risk of tender, and so on. And while in the construction phase, we might even more risks related to unexpected site condition, for example, incompatibility of work method, low productivity of construction workers, increases price of construction materials, scarcity of material supply, heavy equipment damage, changes in the scope of work by the owner, defect, late payment by the owner, and natural disaster. So let's not forget that. So, and then the last phase, the post-construction, the operation and maintenance phase, we might face some risk of the building might collapse early than expected, and then we might have also early defects or handover failure, and there might be some disputes over the contract. Those are examples of risks that we might have. We have different risk management frameworks which we may adopt from the APM, from the ICE, from the Australia, New Zealand code, and from the PMI, and also from the ISO. But we can see some common things here from the process, that it should have the risk identification, it should have the risk analysis, quantitatively or qualitatively, and then risk evaluation, risk treatment, and also the monitoring and control. So we can see some common things here. And this is an example of the qualitative and quantitative risk analysis, where we can see here on the left-hand side, we can use the risk matrix. It displays the probability versus the impact of the risk to a project or to organization. And on the right-hand side, we can see the quantitative risk analysis, where this simulation is performed to run the combination of the probability and also the impact of the risk into the project. And we can then decide which risk is more significant to the project or which risk is considered critical to the project. And then we have to define the anticipation or the strategy of mitigation of the risk. So this is an example of evaluation of project in terms of risk, and we can use also the spider web chart in here. And this kind of example may serve as a platform or providing lesson for similar project in the future. This is also another example of the simulation of risk. This is the quantitative method of risk analysis. Right, now, this is the interesting part. This is about the future of construction. Where we can see here there are 10 features of the future of construction. Number one is prefabrication and modular construction. We might have been seeing it nowadays on the project. It's getting more common. And then number two is advanced building material. And then number three is 3D printing and additive manufacturing. Number four is autonomous construction. Number five is augmented reality and virtualization. Number six is the use of big data and predictive analytics. And number seven is wireless monitoring and connected equipment. Number eight is cloud and real-time collaboration. Number nine is 3D scanning and photogrammetry. And number 10 is building information modeling, or BIM. BIM has been introduced in Indonesia for the last 6 years, I think, and it's getting more common. And even in specific types of project, it is an obligation. This is an obligatory for project which is funded by government's money. So it's getting more popular, and there's a huge demand for BIM expert in this case. So let's have a look in more detail. Unfortunately, until now, the construction industry is considered as among the least digitized compared to other industry. We can see here, it is number 2 from the bottom. Oh. Is it over there? Yeah, it's just not easy to control this. Okay, right, okay. So we can see that construction is just one level better than the agriculture and hunting. So, of course, I'm not very proud of this. So that's why we try to bring the construction industry to the better level with the use of ICT technology, right? So this is BIM. The building information modeling. This is one of the 10 future of the construction industry, which is actually happening now. And we can see here, BIM is actually a platform, a digital platform to work together digitally among stakeholders. So it can be used throughout the project life cycle. Here we can see the use from the concept, from the design, from the construction, operation maintenance, and including the demolition. And just to put it in a simple way, we can see here the old way coordination on the picture on the left, that it is so complex because there are many parties involved in a project. So communication has run along the way with different parties, and that's so complicated. And the BIM is coming to help that as a platform to help the communication between owner, between the architect, the engineer, the structural engineer, the construction management, the subcontractor, the main contractor, and so on. So they can work together in real time, so we can eliminate unnecessary delay in terms of coordination. And we might have many benefits with the use of BIM. For example, like the 3D visualization and resident equation, which I will show you later on. And then for the scheduling, we can see how the project goes along the way. And the 5D cost estimation, and then spatial visualization and dynamic modeling of project, and then strategy and decision making, and reduce rework and increase productivity. Because we actually bring the what will happen on the project earlier to the virtual or digital model. So any error, any mistake, hopefully we can identify it earlier. So there's a feature in the BIM that's called clash checking, where we can check whether the installation of the mechanical electrical will clash or not with the structural elements. So, and that's very useful because that problem happens a lot on the field, and particularly in the past, and it's quite often it is too late because the building is already there, the MEP guy, and then found that their element clash with the structural elements. So actually, there are many, we have now up to 10 dimensions of the BIM. The 3D BIM is about the digital model. The 4D is talking about the time of scheduling. The 5D is about the cost. 6D is about the sustainability. 7D is about management. This is the asset management using BIM. The 8D is about the safety. And the 9D is about lean construction. And the 10D is about industrial construction. In Indonesia, we're still focusing on actually 3D, 4D, and 5D, and very rare to find 6D or even 7D. But we at Undip managed to start an early research on the 8D BIM, which I will show you later on. Okay, this is an example how we visualize the construction process using BIM for risk identification. So by showing the process of the construction of a building, this is especially for a building using what is called prefabricated, pre-finished volumetric construction, or it is abbreviated as PPVC. We can understand the process, and we can understand or we can identify the risk earlier, and then later on we can classify which ones of the risks are critical to the project. And this is another example with showing the risk, the use of BIM to visualize the risk in a project, where we can see here that elements of the buildings can be identified from the risks related to this element. For example, this is the risk related to falling from the height. So for example, we can click on the element, and then there's a window coming up, popping up, and then we can see what are the risks related to this element. So it gives awareness for the safety officer of the project to notice beforehand. So they can control during the project running on the site. Right, so now I will show you some work with my students about the use of BIM, the IT BIM for safety. This is a video. So this is actually trying to simulate the construction process of a building project, where we can put elements of related to safety. For example, like the fence, and then the scaffolding, and some signage of the safety. So we can aware which area which is dangerous for the workers of the project. Right. So this is okay. This is another example where we can identify the element which is critical or having risk to the project, and we can make a list of that. So this is the picture of me doing virtual inspection of a project. This is from a model, and then we try to use the VR, the virtual reality. So I wear the VR glass and try to be in the project digitally. It's like an avatar actually. So I have a video here. Okay, let's play this, see what's going on. Okay. So we can immerse ourselves in the situation and the project. So if you look at on the screen on the television, showing what I see from my VR glass. So yeah, it's not always easy. You need some time to adapt because you are disconnected from the real world. So yeah. The screen, that's what I saw there. So really, I'm disconnected to the real world. It's like I have my own world. See? It's like a strange experience. So I use the Oculus to move from one floor to another floor. Okay. So what we can do here, we can do virtual inspection of the building. So before the building is built, so we can do inspection the area of which are critical, and we can put some notice or some signage there. So this is very useful for, especially for safety officer. Okay. Another video. This is a bit better. So the idea is by having this 3D model, we can let students or maybe researchers to immerse themselves into this virtual reality mode, and then they can learn. So for example, we have some students who wants to experience virtually how the situation in the project, to find the spot which is dangerous to the workers. So they can, instead of going to the project, they can wear this VR glass and try this as their experience. We can also see some truck is moving. When I look up, I can see the building and the roof. Yeah. Okay. Right. So in conclusion, that the construction industry is still hit by many problems related to delays, cost of run, low quality, and low level of safety, and risk is always there depending on the phase of the project, and either for the planning the stage or the post-construction or in the construction. And the BIM is one of the main manifestation of digital transformation, enable the provision of a digital platform for project stakeholders to be able to work together and to coordinate in real time in the construction process and manage construction risks more effectively. Thank you very much.
Okay, thank you, Professor Jati Utomo Dwi Harmoko, for a nice presentation. Okay, we open question from the audience for Professor Sato and Professor Jati Utomo. If there is any question for the two keynote speaker, okay.
Thank you very much, Prof. Prof, in one of the slides, you show us about digitizing of different sectors. We can see that the ICT was in the top and followed by media and followed by many other sectors. And at the bottom was agriculture, and before that, construction. So how do you see the future of construction when it will be digitized, fully digitized? Because now there is some aspect of construction are digitized, but do you think the construction, which is your area, the civil and so on, will be fully digitized, and when do you think it will be like that? Thank you.
Okay, yes, indeed, the construction is just one level better than the agriculture and hunting industry. According to your question, it is not an easy thing to answer, to be honest, because in Indonesia, the construction industry, I mean, the players of the construction industry is vary so much. I mean, we can say nearly 80% of the players in the construction industry is dominated by medium and low-level companies, and whilst the rest, about 10%, is the big project is dominated by the big companies. So I'm not worried about the big companies, but I'm worried with the smaller companies because the number is so huge. And many of them up to now, maybe not really aware of BIM. So it is really a challenge of us in the construction industry to introduce them. And one of the biggest challenges is about the investment, because to implement this, they need not a small amount of money to invest. Even I talked to the big companies early, maybe 4 or 5 years ago. They're still complaining about the number or the value of the investment they have to spend if they have to use this BIM or other digital technology. So really, until everything is getting much cheaper, and then we can face or we can see that this construction industry will be fully digitized. But for how long, God knows.
Okay, I hope that's answering your question, sir. Okay, if there is any question from other audience, okay, there is one. I think there is one question more behind.
Good afternoon. I want to ask for Prof. Jati. Yeah. How the digital transformation contribute for sustainability concept? As we know, sustainability concept not only for profit, but also people and planet. Thank you.
Thank you. This is a good question, how this digitalization might contribute to sustainability. I think this is very related because by this digitalization, we make the process become very efficient. We can eliminate or minimize waste in the project. You know that we are still suffering from many waste in the construction project in terms of materials and also non-material waste. Also we have like the wasting time, the waste of effort and so on, or maybe including the the non-lean process, non-lean process. So we are still suffering from many inefficiency. So with the presence of digitalization, I believe this is one of the answer of getting more sustainable. The more digitized, the more efficient, the more sustainable our project and our industry.
Okay, thank you. I think due of the time, okay, one more big focus from Professor Teddy.
Thank you. My question is not go to Prof. Jati, but my question goes to Prof. Sato. Is he still here?
Okay, I will check. If Professor Sato is still connected with us?
Yes. Yes, thank you for question.
Okay.
All
There
right.
is one question from Professor Teddy Mantoro. Okay,
All right, yeah.
you can just speak.
So, Prof. Sato, really thanks for your very nice presentation, really inspiring me. My question is in relation to your work, in musculoskeletal medical image analysis using AI, especially. All right. So my question is, are you consider about the electric thing inside of the muscle? If yes, when you implement it in the AI, is there any way, as a lot of people actually try to, try to build strong muscle without any exercise. Is it possible to do so? That's number one. Number two, a lot of people want to have like weight loss. Is it possible to use your approach and we can lose our weight without any exercise? Thank you, Prof. Sato.
Okay, I think Professor Sato, please, you can answer the question.
So thank you very much for question. So maybe your question might be our system can monitor or maybe can optimize weight loss and muscle strength.
Yep, that's
So maybe, I think our system use X-ray. So maybe our system may not be very suitable for. Our system may not be very suitable for young people, but maybe middle-aged people. Maybe our system will be very useful for that maybe purpose, I think. So our system is very easy to apply. So I suppose also in Indonesia, so in many clinics, a plain X-ray system will be available. So if you have plain X-ray images, you can easily estimate what each muscle mass and bone mineral density. So our system, I hope, will be useful for maintaining our musculoskeletal system. Thank you. Is it okay?
It's okay, Professor Teddy? Okay, thank you, Professor Sato. Okay, I think due of the time, I need to close the question and answer session. Please big applause for both of the speakers. Okay, I just want to little summarize for the work of the Professor Sato, as the mention is like the work is for to present how to address the black box problem and the annotation cost problem, which is considered to be weak of point weak of I. And from the Professor Jati, it can be summarized that he considered about the risk management, how to implement that in the life cycle, how more effective construction with the digital era. Okay, thank you everyone. I think thank you for the good speaker and share. Okay, I return the session to the MC.
Okay. Yeah. Check. Yeah, okay, thank you very much, moderator. Well, ladies and gentlemen, as the uniqueness of Semarang, we proudly present the Wara Dukder dance performance from Semarang University Student Activity Unit. Please give big applause. Yeah, okay. Thank you very much. Such a beautiful dance. Yeah, well, ladies and gentlemen, now here we come to the next agenda. Now we will hear about the remark by the General Chair, First Icteca 2023, Professor Dr. Insinyur Teddy Mantoro, MSc. Okay, for Professor Teddy, the time is yours. Yes, remark, closing remark. Yeah, thank you very much.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon to everyone, to ladies and gentlemen. Let me call a couple of my friends first, yeah. So our Honorable Professor Dr. Insinyur Sri Budi Wahyu Ningsih MP, the Vice Rector for Academic, USM, and then Dr. Titin is not here. Prof. Sesi is still here, not here also, and Rector is not here. That's okay. So all deans, professors, doctors, distinguished guests, and esteemed Icteca participant. Alhamdulillah wa syukurillah, we have successfully come to the closing of the first international conference on technology, engineering, and computing application, yeah, 2023. I would like to express my deepest gratitude to all participants, speakers, members of the organizing committee. Maybe I can mention here a couple of the organizing committee who help us a lot to make this happen. To Dr. Ferry, of course, and then to he is the co-chair, co-general chair, and also Dr. Yuli, and also one very important guy here, Pak Udin. Yeah, I don't know the full name, by the way. Sorry to call you Pak Udin. And then also Pak Saiful, who helped us in arranging all the connection and so on. Yeah, Zoom and so on. So, Bapak Ibu and ladies and gentlemen, this is actually not easy stuff, yeah. When we running parallel session, for example, and then a lot of people come in. If we are not in a good hand, they usually have some troublesome. And at the moment, we saw like the process of the two session, 6 track, and with the 5 until 6 papers, we see like all works smoothly. And also I would like to thanks to everyone who has contributed to the success of Icteca 2023. This event has truly served an invaluable platform for exchange of knowledge, idea, and innovating thinking. I am pleased also to inform you, everyone, the 64 papers, they already presented. Some of them still some problem at the moment, 2 or 3 paper, we are going to solve it out. We are scheduled to upload it to IEEE Explore within 1 or 2 weeks. So during the presentation, if there is some small mistake, for example, there's still some chance for everyone here to fix it, and then sending it to us, but only for 1 or 2 weeks. But after that, we are going to submit it directly to the IEEE Explore. The expectation to be accepted by IEEE Explore, we need to wait until about 2 months. That's in the normal situation. And after that, after sitting all the paper in the IEEE Explore, we need to wait again for another 2 or 3 months to be indexing by Scopus. All right. But by the way, everyone, just for your information, I'm the chair for IEEE Computational Intelligence Society in Indonesian chapter. Every single year we sponsored around 4 until 5 conference. We lucky, almost all currently that we sponsored, they always goes to the Scopus so far, all right? But in Indonesia itself, around 15 until 20% of the Indonesian conference under IEEE, they are rejected by IEEE, all right? So please don't so happy first until this stage. We need to wait, until everything going smoothly. For those who already presented, as you can see, you can read also over there, our instance conference is about the technology, about the engineering, and about the computing application. There is some possibility, some paper maybe not fit in our conference here, not related with the engineering, not related with the technology, or not related with the computing application. So I still give you a time for 1 or 2 weeks to fix it and then submit it to us. Why? Because among the 4 conferences that I sponsored this year, one conference, they call it ICOCIS, we have 13 papers, they are rejected because of outscope. And for your information, the paper actually came from the big university like University of Indonesia and ITB, by the way. Okay? We working in the security part, they propose in mathematical side. And then some of them, they say like this is not computer security, but this is about the math. So we don't want to have this kind of thing. We already work in detail, but some of the paper, because so many people came from different background as the reviewer, there is some possibility 1 or 2 paper can be, go to this area. All right. So, and again, everyone, we don't want to have some bad record in the first instance that we do here. So then please help us to fix your paper in the case your paper is out of scope of our conference. Okay, and as everybody knows, our papers already check and double check in terms of the plagiarism level. Just like I mentioned in the morning, that we put it like the maximum only 20% of the plagiarism level using Turnitin, for instance, and then only maximum 4% for one reference. Okay, so I think that's already done so far, and all the format also already follow the IEEE format. Last night, everyone, among the 64 paper, we find out around 43 paper is not comply with the IEEE Explore. All right. What kind of problem that usually we have? This is also our learning process for those who going to submit again to the other conference. So your paper should be comply with the IEEE Explore. The first one, the mistake that we find, in the first page, usually there is some like coding, X and something. All right. Because we are not in US, so you need to remove that. So we have like 43 papers still do the same thing. Okay, except for my student, of course, because I mentioned to them you need to fix it using this way. And then the second one is in terms of the author. So if you have like a column, because you have some certain column, right? 3 column, for example, your paper, you have like five authors. If you put in that format, so 1 column, 1 author, you can put only 1 organization. You cannot put in terms of column, you put like 2 organization, right, everyone? So what happen if you, for example, belong to Undip and at the same time you belong to USM? Then the way you do, you put all the name in 1 column only, not several column, not 3 column, but 1 column, and then down there you put like the first one will be this organization, the second one this organization. Then you put the pointer in the top of that. That's the standard of IEEE. So we still find 2 or 3 papers still do the using that way. Yeah. So we lucky, the committee was quite nice. We asked them not only submit the PDF Express, but also they also submit the MS Doc. So the committee working until a little bit late last night. So they fixed everything. Now already in the good hand, by the way. The other thing, yeah, everyone, as the committee also not that easy, because when you submit, we have your PDF, sometimes with the number, but there is no guarantee that your PDF actually created by PDF Express from IEEE. So then what we do, all the paper they submitted to us, we going to double check, yeah, to make sure that everything should be there. So they guarantee for us that that's all the effort that we do to make sure all the paper will be, you know, goes to the IEEE Explore. So that's why we, at the moment, a little bit confident that we are going to reach until the paper will be accepted with the Scopus, by the way. And everyone, when the time, for example, your paper already in the IEEE Explore, we are going to announce to you. Just in case your paper is not there, let us know. All right. So we have couple of weeks or 1 or 2 weeks to fix, to work together with the IEEE Explore people. But in the case your paper accidentally lost from IEEE Explore, let us know also. And the way I do, the way we solve this kind of problem, we keep the paper for the next round of the Icteca, for example. We are going to insert your paper. For you, no need to do any payment, no need to do any presentation, and so on. And we're going to submit it right away in the next round. So, everyone, one last announcement, I think, from the General Chair here. Today is the first day of our conference, and tomorrow still our conference also, even though we already closed today, because tomorrow we still have one agenda actually. This is for relaxation, to have some networking. Yeah, that's why we call it as the social network tour. So for those who interest to do some tour in the city only, by the way, please register in the back there. All right. If you're not registered, then of course you will not be able to join our tour. Ladies and gentlemen, Bapak Ibu ya semua, on behalf of the organizing committee, we extend our sincerely appreciation to the Semarang University, and also to organize this conference, and also we would like to acknowledge the valuable support from the technical sponsor, which is IEEE, CIS, Indonesian chapter. We are excited also to, this is temporary announcement because not final yet. We are going to running the ICT for Icteca next year, 2024. The location, the place, and the time will be announced later on. Okay. And why we mention that way, with the expectation everybody here who joined this conference today to prepare your better work, and then next year hopefully you can meet us again with better quality of your paper. This conference has seen remarkable results presented across various research fields. However, we acknowledge that there are still have the technical error or unintentional misdirection, especially from me during the conference. So we ask for your understanding and forgiveness in this regard. With that, I would like to extend my gratitude to everyone again, and eagerly anticipate our next conference. As your journey going back to home, please prioritize your health and also your safety. So again, thank you. May you all return safely. Wassalamualaikum warahmatullahi taala wabarakatuh. Thank you everyone.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Teddy. Now, here we come to the best paper of the first ICT Asia 2023 presented by Semarang University. Okay, we have three best paper here. The first is the paper entitled Architectural Design of Electricity Power Consumption Misuse Detections Based on Live Gradient Boosting Machine Using Blockchain Technology. Saiful Hadi, Wahyu Amin Syaifi, and Adi Wibowo. Please, for the representative from this paper, you can come forward on the stage. And the second paper entitled Estimations of Remaining Useful Life in Lithium-Ion Batteries Using Bidirectional Long Short-Term Memory. Denis Eka Cahyani, Faisal Faris Setiawan, Anjar Dwi Hadi, Langlang Gumilar, and Ahmad Kadri Juno. Please come forward on the stage. And the third best paper, with the paper entitled Semi-Automatic Model for Detecting the Discrepancy Between Cadastral Data and Building Footprint Extractions Using Unmanned Aerial Vehicle UAV Leader in the Perspective of Smart City by Ahmad Gamal, Faris Zulkarnain, Satria Indratmoko, Ardiansyah Lailatul Rohmah, and Arini Musfiro. For the representative of the paper, please come forward. To give the prize for the best paper, please Professor Budi to come forward on the stage to give the prize for the first best paper. Okay, Prof. Budi, you can stay on the stage. Yeah. The next is Ibu Titin, the Vice Rector to Semarang University, to give the prize for the third best paper today. Thank you very much. Yeah. Take a picture together. Thank you very much. Yeah, for the best paper, you can go back. And Bu Titin, please stay on the stage because we will have souvenir sessions for today. Okay. In these souvenir sessions, please come forward, Professor Teddy Mantoro and Professor Media Anugrah Ayu, to get the souvenir session from Professor Budi. And the next souvenir for Professor Media Anugrah Ayu will be given by Professor Budi. For the next, Professor Akram MZM and Professor Jati Utomo Dwi Hatmoko, please come forward on the stage to get the souvenir. Okay, the souvenir for Professor Akram and Professor Jati will be given by Ibu Titin Winarti, the Vice Rector too. And then next, the souvenir for Professor Jati Utomo Dwi Hatmoko will be given by Ibu Titin Winarti, the Vice Rector too. And then next, please welcome our lovely moderator, Ibu Dinar Mutiara Kusuma, PhD. Please come forward on the stage. And the souvenir will be given by Bapak Ferry Firmawan, PhD. And next is photo sessions together. Okay, thank you very much. For keynote speaker of the ICT HR 2023. And congratulations on the best paper today. Well, ladies and gentlemen, the following agenda is the closing remark by the Vice Rector of Academic Affairs. Please welcome Professor Dr. Insinyur Sri Budi Wahyuningsi, MB. The time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Dear Honorable Prof. Teddy, Prof. Media, Prof. Jati, Prof. Akram, Mr. Titin, and the colleagues, professor, lecturers, researchers, ladies and gentlemen. Alhamdulillah wa syukurillah, we have successfully come to the end. USM, the first international conference on technology, engineering, and computing application, IEEE conference, 2023. I would like to express my deepest gratitude to all participants, speakers, members of the organizing committee, and everyone who has contributed to the success of Icteca 2023. This event has truly served as an invaluable platform for the exchange of knowledge, ideas, and innovating thinking. On behalf of the organizing committee, we extend our sincere appreciation to Professor Dr. Insinyur Teddy Mantoro, MSc, as General Chair of First Icteca USM and the committee. This conference has seen remarkable results presented across various research fields. However, we acknowledge that there may have been technical errors or unintentional misdirection during the conference. We ask you for your understanding and forgiveness in this regards. With that, I would like to extend my gratitude to everyone and eagerly anticipate our next conference. As you journey back home, please prioritize your health and safety. Thank you, and may you all return safely. And this international conference, Icteca 2023, is officially closed. Thank you for all. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Ladies and gentlemen, here we go to the end of this international conference. Please give applause to Icteca 2023. Yeah. We look forward to see the fruitful of this Icteca 2023 in the years to come. Thank you once again to everyone who has made this partnership possible. Thank you very much for your attention. See you in the next Icteca, and goodbye. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
There's a power